Good afternoon, everyone. So, welcome to Functional and Conceptual Design course. So, every Monday, we have planned to have a live session from 2 p.m. to 4 p.m. I'm Dr. Ramya, Assistant Professor from Department of Electronics and Communication Engineering in Sri Venkateshwara College of Engineering. And I'm working under Professor Ashokan sir in Department of Engineering Design IIT Madras, and I'll be acting as teaching assistant for this course. Let us wait for some more time so that more participants can join. So, I think we can start. So, we are going to discuss functional and conceptual design. This course will help us solve real world problems. It will encourage us towards innovation. It adds economic value, promotes sustainability, and it helps in building better engineers. So, my contact detail is given here. You can ask me if you have any doubts. My email ID is ramya@svce.ac.in. Or you can also post your doubts in the Google forum, which I'll be able to answer. So, moving on to the next slide. This is the course summary. We started the course on 20th July and we are currently in the 4th week. Your examination will be on 25th of October. Within that time, we'll plan for 12 live sessions or interactive sessions so that you can learn some of the numericals, and we will also discuss about your assignments, and you can open up about your doubts anytime during this live session. So about the course, this course introduces engineering design as a different from the conventional design engineering. Here you can learn the importance of system, identify various steps involved in the design process, learn the importance of function and form in the design process, and apply the systematic design process for product development. This course is intended for undergraduate and graduate students who are interested in new product development. The week-wise course content is listed here. Week 1, you would have listened videos about introduction, birth and growth of a product. In week 2, we discuss types of design, stage gate and spiral design, stages in new product development, and laboratory exercise 1. In week 3, we have reverse engineering and redesign, technical equipment, and we discuss laboratory exercise 2. In week 4, that is the current week, we'll be discussing about identifying customer needs, customer need analysis, product specifications, and laboratory exercise 3. In the upcoming weeks, every Monday, we'll discuss about the week topic, current week topic, and we'll also discuss the laboratory exercise so that it will be helpful for you to take up the assignments. So this is an AICTE approved FTP course. If you're not yet registered for the examination, I think you can do it as early as possible. Moving on to the learning outcomes. By the end of this course, the student should be able to understand the systematic design process. They should be able to identify and understand the customer needs, develop clear engineering specifications, generate multiple creative design concepts, evaluate and select concepts scientifically, and design better products. So our aim is to design a better product. That is, we'll go from the need to the product. We'll understand what the needs are, then we'll go to defining of problem, then we'll generate ideas, evaluate the concepts, design and develop the chosen concept, then we will test and validate it, and finally we'll design our final product. So even after all these process, why do some products fail in the market even though they work technically? So to understand that, you have to complete this course. When you complete this course, you should be able to understand what is missing in that product and how it can be redesigned and made as a successful product. So some of the reasons for failure may be poor usability, high cost, unattractive appearance, or it may not meet the customer needs, and it may have poor reliability. So because of all these reasons or any one of the reasons, the product may fail. You will be able to design or redesign a product from an engineering design perspective after completing this course. So what is a design? Design is a creative possibility, but you cannot say it is just creative, because creativity gives us possibilities. Engineering design gives us a process of turning those possibilities into useful products. So it is a systematic procedure or customer needs. So why do we go for? Then it promotes sustainability, it builds better engineers, and it enhances creativity and problem solving skills. So the best way to predict the future is to design it. And who does the engineering design? Everyone: engineers, designers, innovators, and problem solvers in every field, from technology and healthcare to transportation and every environment. Everybody does the engineering design. So what is a good design? A good design makes things work, better designs make things better, and best design makes the future. So only when your design is the best, it will become the ruling product in the future. So you would have observed engineering design in our world. For example, smartphone, it is one of the best engineering designs. We have cars, which is a result of design. We have various medical devices which saves our life. Then we have renewable energy. wearable devices, and industrial robots. All are end products of engineering design. So engineering design is the bridge between ideas and impact. So let us understand what is engineering design and industrial design. For example, engineering design concentrates on function and concept, that is, what the product is supposed to do. For example, if you take a kettle, it is supposed to boil the water. So what is the purpose of the product is function. And engineering design concentrates on the function, performance, reliability, materials and process, and the safety of the product. But what is industrial design? Industrial design means it gives more importance for form. Form means how the product physically looks and how it feels. So it describes the shape, size, proportions, appearance, materials, and finish of the product. For example, what is the shape of the kettle? What is the color? How attractive it is? How is the handle? How it is comfortable for the users to hold and lift the kettle? The material used for making the kettle, the surface finish, it is metallic in finish. All that is concentrated in industrial design. For a product to be successful, we need to give importance for both function and form. So function is what it does. Concept means how the function could be achieved. For example, to achieve the functionality, we have to choose a concept, like how we are going to do that function. So that is concept. Now I think you would have understood what is functional design and conceptual design. Function means what the product is supposed to do. Concept is how we are going to achieve that function. And form is more physical, that is how it looks and how it is going to appear in front of the customer's eyes. So now you understand the two sides of the same product, that is function and form of a product. This function and form is very important for us to understand the success of a product. So just now I explained what is product function and product form. So if you take an example like fan, the function is to circulate air. If you take the product as camera, the function is to capture images. If you take a water bottle, it stores the water. So it defines the purpose. Function defines the purpose, performance, and output. So if you look at the form of a product, it tells us how the product looks and feels. For example, if you take a smartphone, it has a smooth finish, attractive color options, lightweight, and comfortable to hold. These are the product forms. So this means it defines the shape, color, material, size, appearance, and ergonomics. So would people buy a product or a mobile phone if it is too heavy to carry? Even if it is powerful, and if it is not having any comfort in the form aspect, people might not buy it. For example, it is powerful but it is too heavy to carry, too uncomfortable to hold, and what will the customers do? They'll go for a better product which is of lightweight or which is easy to carry. So the form and function both are important. Function is the foundation. On that, the form should also be suitable. Only then they will buy. So a good product balances function, that is what it does, and form, that is how it does, for the best user experience. So creativity in engineering design. What is creativity? Creativity is developing new and useful ideas that satisfy human needs. For example, a foldable phone. It is a creative idea. What it does, it combines portability with a larger display. The second example is self-cleaning water bottle. So instead of having a plain water bottle, which may accumulate bacteria over time, you have a self-cleaning water bottle that keeps water clean using UV technology. The third example listed here is a sanitizer dispenser, which is touch free. That is, you need not touch anything. You go and place your hand, automatically it senses your hand and gives the liquid or the soap liquid automatically. So these are creative products which make our life easier. So what does a creative product do? It solves the problem, it saves our time, reduces effort, improves comfort, and it also reduces cost. So now I request every one of you to think of a creative product and then share it among yourself. You can try this as a homework with your friends. So creativity turns ideas into innovations that makes life better, easier, and smarter. So now let us look at the typical design process, that is from customer needs to product. So first we need to understand what is the need of the customer, that is understand the needs, wants and expectations of the customers. Then clearly we have to define the problem and identify the core issue. Then convert these problems into engineering specifications, that is the needs should be converted into measurable technical requirements. After converting to engineering specifications, you have to generate as many ideas or concepts as possible to solve the problem. After many ideas are available, we have to evaluate the ideas or concepts and select the best based on a criteria. So I'll repeat the first 5 steps. First, we need to understand what is the need of the customer. After understanding the need, we have to define the problem. Once the problem is defined, you have to convert it to a measurable technical requirement. Once it is done, you have to generate as many ideas as possible or as many as concepts possible. Once the concepts are ready, you have to select which one is the best among all the ideas. After that, you need to go for detailed design, that is create detailed drawings, models and documents for production. Once the designs are ready, you need to build a prototype to validate the design and functionality. Once the prototype is ready, you test the prototype for performance, safety, reliability and usability. And the final step is refine and manufacture the final product for the market. So these are the 9 steps that happens in the design process, that is from customer need to the final product. I'll repeat the 9 steps. Understand the customer need, define the problem, go for engineering specifications, followed by concept generation and concept selection. Then you go for detailed design of the product, build the prototype, test it and manufacture it after refinement. So what is the outcome? A good design solves the right problem in the right way. And by now, I think you would have understood engineering design is a systematic process, not a guesswork. So if it is done as a systematic process, you get all the benefits. That is, you can make the product with the right cost and you can also address all the needs of the customer and build a successful product which is acceptable by all the users. So first let us look at the 2 types of design, that is analytical versus synthetic design. So what is an analytical design? This design solves an existing problem. For example, there is a vibration in the vehicle. You want to reduce that vibration in the vehicle. So you analyze the problem and then you go for the design solution. Or you want to improve the fuel efficiency in an existing system, you can work on it and then design a solution for that. So the third example is reduce product weight. So these are examples present in an existing system. These problems are already present. You want to analyze the problem and give improved solutions so that you get a better product. Now let us see what is a synthetic design. So synthetic design means you create something completely new. For example, smart glass, virtual reality headset, or a flying taxi. All these things are not present in the world right now. You imagine a new idea, uh, do the concept, create the concept, prototype and build it, and you launch a new product. There is a risk involved in this design, but it is completely new and creative. So analysis improves existing products and it makes it better, whereas synthetic design creates a completely new product. So what is this image? Can you just look at it and understand what it is saying here? So this slide shows the evolution of camera. Initially, before 1500s, people used to uh, capture their memories through paintings. We did not have cameras, so an artist used to spend a lot of time and draw the picture. Later, they invented camera. The first camera was camera obscura, where they used optics to record the image using light and optics on a wall. So after that, the artist used to trace and then find out what is the image, and after tracing, they used to store the image. In 18th century and in 19th century, we used film cameras which captured images on the film permanently. After that, we came to a digital camera where we stored the images digitally, and the chemical films were not used. This was in use till 2010. Now, in the present day, we have smartphone camera, which are high quality cameras in our pocket. The size has reduced. It has lot of smart features, and you can even edit the images right way. So all these facilities are available. But do you think it will stop here? No, it is never going to stop because the evolution continues on and on. Every new generation of cameras was developed to solve the limitations of the previous generation. So, what was the problem with the digital camera? The size was big. You need to have an explicit device for taking photos. Now we have it in our mobile phone itself. It is an added on feature in the mobile phone. So, we have solved the limitations of previous generation. But we are not going to stop with this. We look for the limitations in this device and then go for a new or creative design. So we are going to meet the changing needs of the user, and the evolution will never stop. The design is never going to end. So what are the key takeaways of week 1 course? Engineering design is systematic. The products are developed to satisfy customer needs. Good products combine function and form. This is very important. It is not sufficient if you concentrate only on the function. It is very important to give importance or combine both function and form. Only then you will be able to design a successful product. Creativity is essential for innovation, and products continuously evolve with technology. The evolution is not going to stop. Successful engineers understand customer requirements before designing. So, great design starts with understanding people, that is, understanding their needs, solving the right problems, and creating value through thoughtful solutions. So, here I have pictorially represented how we are going to design and solve a problem. You have to identify the needs, define the problem, design the concept, develop it, make the prototype, evaluate, and then design a successful product. So this is going to continue like a cycle. So this is the summary of week 1. Now let us go to week 2 syllabus. So who are going to do this design? The frontline troops, that is the designers, are going to make it. So what is a design? It is not merely drawing a product. It is making decisions that shape the product. So you need to make the right decisions at the right time. Only then you can shape the product. So product design involves both risk and opportunities. So sometimes the product may fail and it might be a huge loss in terms of cost also, and time, cost and time. And there's a lot of opportunity to hit the market and make a huge success. So there is both risk and opportunity involved, and product designers are the frontline troops who lead and execute the product development. And new product design is a key competitive activity for companies. So companies work on the technology, market, and the right time to make a successful product. What is the key principle involved? The level of engineering required determines the type of design that you're going to use. There are different types of design which we will discuss today. So the level of engineering required for making that product decides the type of design. Let us move on to the different types of design. Before that, if you look at the IBM products, you get an understanding of the products, how they are designing it, and what are the methods that they followed. Great designers create value by integrating technology, market, and time to deliver products that succeed. So let us go to the different types of design. There are 3 major types. The first one is original design, the second is adaptive design, and the third one is variant design. So original design means it develops an original or a novel solution for a given task. The result is a new invention. So for example, in the 20th century, they invented transistor, which ruled the world for the next 100 years, and still it is ruling. So transistor is the original design. Microprocessor, anti-lock brakes, CD, that is for storing data, CD media. So all these are original designs. Now let us see what is an adaptive design. So adaptive design means you already have a system to solve the problem. You're going to make some modifications in the system or make that system adapt to a new requirement. So it adapts a known system to a change task. A significant subsystem may evolve. It does not require complete restructuring of the product. For example, the existing system is a wheelchair. You already have a wheelchair to support the people who require it, but this wheelchair is not suitable for staircase. So you're going to adapt it for a new task. That is, the wheelchair should be able to claim. That is, it can be used for climbing the stairs also. You're not going to change the system completely. You're going to make some modifications so that it can adapt to a new task. So this is adaptive design. And the third one is variant design. That is, you select a parameter and modify that parameter of an existing product. For example, size. So same product can be manufactured in different sizes by changing the dimensions, or you change the geometry, change the shape of it, and make it as a variant design. You change the material properties or the control parameters alone. So here you have the same watch, that is the function is the same, but you have changed the uh, form of the watch. So this is variant design. So I think now you would have understood the three types of design. The first one is original design. That is, you develop an original or a novel solution for a given task. The result is an invention. The second one is adaptive design. It adapts a known system to a changed task. A significant subsystem evolve, and it does not require complete restructuring of the product. The third one is variant design. It modifies the selected parameters of an existing product. That is like size, geometry, material properties, or control parameters. So designers choose the right type of design approach based on the task, goals, constraints, and the degree of change required. So among the three, you can choose any one based on your own requirement. So it is not necessary that you have to go for um, original design all the time or any particular design always. Based on your requirement, you choose the type of design methodology. So here I have examples for the three types of design, that is original, adaptive, and variant. So the first one is original. Um, so what is the basic idea? You create a new solution. The example given here is anti-lock brakes. The second design is adaptive design. You adapt an existing system to a new task. So this anti-lock brake system, you adapt it for heavy trucks. So when you do that modification, it is adaptive design. The third one is variant design. You change the parameters without changing the basic configuration. So you go for a different disc diameter or a friction material, then it is variant design. So this is brakes example. Like this, you can consider different examples like steering, entertainment system, computing, vehicles, and gearings. So the key point here is redesign does not mean only variant design. A redesign can use original, adaptive, or variant design. You can redesign a product with any of the three methods. It is not necessary that changing the parameters is a redesign. Okay. So a redesign can use original, adaptive, or variant design approach when an existing product falls short of some requirement. So please make a note, redesign is not same as variant design. Redesign means that a product already exists, it falls short of some criteria. So a customer is already using it, he tells you what are the drawbacks present in it, or you come up with some drawback in that product. Then you find a new solution through any of the three methods, that is original, adaptive, or variant design. So I think you're clear with the three types now. Now let us go to the process models. So the product development process models are listed here. I'm going to discuss two models here. One is stage gate model and the other one is spiral process. So here you can see stage gate means for every stage you have a gate. Gate means it is like checkpoint. The literal meaning. What is a gate? Only if you meet out the criteria, you pass the gate. For example, you are entering your college, you have an ID card. Only with that pass, you can pass the gate. You can go through the gate, right? So that is what is meant by stage gate process here. For every stage, you will have one examination point, that is the gate. So at that point, you decide whether to go with the process, that is, go to the next step of the process, or kill the process there, or kill the decision and go for a different method. So this is called stage gate process, or sometimes it is known as waterfall process also. So in stage gate process, stage one is discovery, that is discovery of the customer need or the problem. Then before you go to stage two, you have gate one. After passing the gate one, you have scoping. Then you go to the third stage, that is business case. Then fourth stage is development, followed by fifth stage, testing and validation. And finally, you launch after you pass through all the 5 gates. So development is divided into stages. Each stage is followed by an evaluation gate. The project proceeds only when the gate decision stops continuation. Sorry, the project proceeds only when the gate decision supports the continuation. So what is the key idea? Move forward in a structured way, evaluate at each gate before investing more. So this is one method. The other method is spiral process. That is, everything is done in a cyclic manner and the cycles are repeated. So the first step is plan, define the objectives, alternatives or constraints, then do the risk analysis, identify or resolve the risk, develop and test, that is build, integrate and test the product. Then you go for review, that is evaluate with stakeholders, and finally you go for the next iteration, that is you repeat what is planned, risk analysis, develop and test and review. So at the end of every cycle you may get one product, but that may not be a complete product. Partial product will be obtained at every stage. After a number of cycles you get the final product. So the development proceeds through repeated cycles. A partially working product can be obtained early, so each iteration adds a functionality. So what is the key idea in spiral process? You learn early, reduce the risk and progressively improve the product through iterations. So I think now you have understood what is stage gate process and spiral process. I just wanted to show the stage gate process in detail. The steps are given here. So the stage gate flow is listed here. You can have a look at the 11 steps. The first one is discovery. Then you have idea screening, followed by scoping. You have second screening, then you build the business case, go to development, go for testing after that, testing and validation, then you go for launch. But in between every stage you have the gate which will tell whether to go or kill the process. So a decision point in the development process, and the management team evaluates whether the project should proceed or not, and the project must successfully pass through the gates towards the project launch, towards the product launch. So, what is the advantage? Money is saved here, so you don't go in the wrong direction. Early gates, and it checks the market opportunity and feasibility. Later gates check detailed development and integration, such as software hardware interaction. So, these are the benefits. Sometimes you call the stage gate model as waterfall model, but few books differentiate both, because the difference is that in the waterfall method you go stage by stage, but the checking is not so crucial in every gate. In stage gate model, you check and decide at any time you may kill. So that is the difference between stage gate and waterfall. But as far as our syllabus is concerned, you can consider them interchangeably. So moving on to the spiral model, a spiral product method. Uh, Spiral product means you're going to do this in a cyclic manner. That is, you determine the objectives, then you um, go for solutions for this, then you develop and test it. After that, you plan the next iteration. This is going to happen in a cyclic manner, that is iteration 1, iteration 2, and so on. So each iteration will have objectives, risk analysis, development and testing, followed by reviewing. So this is a cyclic process, and in the first round maybe you will get the basic features of the product. In the second iteration you'll get more features, and in the end result, you will get a complete product. So it repeats the development process several times. A partial working product is obtained at the end of each cycle. Each iteration adds functionality or improves the product, particularly useful in time compressed industries such as software. So in software industry, spiral model is preferred. The product may initially be incomplete, but it works. For example, word processing software, um, they followed spiral method and they created a basic features one first, then they added the features in the every step or in the every iteration. So what is the key idea? Each spiral cycle produces progress, um, plus learning plus risk reduction. So now let us look at the um, product development phases. There are three phases. The first one is understanding the opportunity, second one develop concept, and third one implement the concept. So under understanding the opportunity, we develop a vision first, then we go for market opportunity analysis, then we go for customer need analysis, and finally competitive analysis is done. So what is develop a vision? We need to have answer for these questions, that is what the product should do, or what is our wish, what a product do we wish to make, what is difficult with the current product, what should the product do to be better. And next we go for market opportunity analysis. So what is market opportunity analysis? Can the vision be successfully realized? Can the product be developed and implemented profitably? So this is the second step. And the third one is customer need analysis. So what does the target customer want the new product to do? Then finally competitive analysis, that is study existing competing products. For example, um, what we design might be available in the market already. If you want to make a phone, it might be available already. So there are competitors present. You have to study them to make a better product. Evaluate how they satisfy the customer needs. So the four steps are understand the market, understand the customer, understand the competition, and then identify the opportunity. So moving on to developing a concept. So there are three steps function involved here: functional modeling, product architecture development, and concept engineering. So what is functional modeling? Determine what the product must do to satisfy the customer. So you have to understand the customer's needs and then form the functional modeling. Then you are going to develop the product architecture. You have to identify the interfaces between different elements of the product. So there might be 4 or 5 elements present inside the product that you're designing. You need to identify them and the interface between those products. Then you have to go for concept engineering, that is you generate multiple concepts for implementing the functional specifications, compare the alternative concepts, select a suitable concept for further development. That is, you have 3 concepts here, you choose the best one based on the need and then proceed with that concept. So at the end of opportunity analysis, a gate evaluation can determine whether the team should proceed with the concept development. So you do the opportunity analysis, then after gate evaluation, that is go no decision, um, you go for concept development, then you proceed with the development. So the final step is implement a concept. Once a concept is selected, it must be converted into a realizable product. For that, we have 4 steps. They are embodiment engineering, modeling, design for X, and robust design. So what is embodiment engineering? You turn the selected concept into a physical product. You give a form for it. That is, you give a body for it. Specify the components to purchase. You specify the parts to manufacture. Define assembly specifications. Develop the physical realization of the product. That is embodiment. Then you go for modeling. Use models to analyze and validate the design. You may go for physical modeling or analytical modeling. That is, you make prototypes, mock-ups, and do the experiments on it. Then analytical modeling is doing simulations, calculations, or performance prediction. Then design for X is design for specific product requirements, that is design for manufacturability, design for cost, design for serviceability, or design for sustainability, or design for safety. Like this, you have so many options. So generally we say design for X. Then robust design, develop a design that performs reliably under variations and uncertainties. That is, under extreme conditions, how it performs. Consistent performance despite variations in noise, environment, materials, and usage. So the implementation flow is listed here. You selected a concept, then you gave embodiment for it, then you did modeling and analysis. After that, you designed for various requirements, then robust design. After that, you get the realizable product. So what is the key idea here? A good implementation makes the concept work reliably, economically, and sustainably in the real world. So with this, week 2 is over. What are the three types of designs that we discussed? Original, adaptive, and variant design. And we saw there are two types of process methods. One is stage gate, the other one is spiral. What is stage gate? It suits structured planned development. That is, at every step it is a series of stages where you have gate between every stage. In the gate, you say whether to proceed with it or you say a no for it. So yes or no, you decide whether it is accepted or not accepted, go or kill. That is stage gate process. Then you have spiral process. That is, you do it in a different number of iterations. So after one iteration you may get a partial product. You go through a number of iterations, which is repeated cyclically, and then finally you decide the product. And what is the third point here? Every product's journey begins with understanding the customer needs, and it ends after extensive refinement. So this is your summary of week 2. That is, we discussed three design types: original, adaptive, and variant. Then we saw what is stage gate and spiral. Then we saw the 3 points, that is understanding customer, then developing a concept, and implementation of a concept. So with this, week 2 is over. We'll go on to week 3 syllabus, that is reverse engineering and redesign. So first, let us understand what is reverse engineering. Reverse engineering starts with an existing product available in the marketplace. So the existing product is studied to understand what the product should do, how it performs, its underlying functions and structure. The product can be modeled, analyzed, or dissected and experimentally evaluated. For example, the existing product is a bread toaster. Then you analyze or dissect the bread toaster and understand the product completely. Okay, so once you understand, you can identify the opportunities and go for redesigning. So you find out what the gaps or defects or opportunities are there for enhancement. So you can look at the first three steps here. The first one is reverse engineering. You start with an existing product in the market. After you start with the existing product, you understand the product. How do you understand the existing product? You study, analyze, and evaluate its performance, structure, and functions. Once you understand, you identify the opportunity, that is, what is the gap or what are the defects or what are the things missing in this existing product. Once you do that, you can go for redesign, that is, you can reimagine, improve, and evolve the product, and you can produce an improved product. So redesign follows reverse engineering. The objective is to evolve the existing product into its next improved offering. So you can look at the two pictures. The existing bread toaster does not have a digital display. Here it displays time and temperature so that the user will get a better idea. So this is the improved product now. So you deliver greater value to the customers and the market. So you start with reverse engineering, you understand the existing product, identify the opportunities, and then go for redesign. Yes, Rishabh.
Ma'am, I have a question.
Yes, please.
While doing the reverse in the process of reverse engineering, like you said, you need to understand the user needs, and if the current product that we are reverse engineering have any like loopholes or whatever. So, in order to do the user research, should we go with the qualitative research method or quantitative research method or mixed method approach why in the reverse engineering process?
See, in the reverse engineering, first you understand what is the existing product. For that, you're going to analyze it and dissect it. When you do that, you can understand what is missing. It is not necessary that you have to go for qualitative or quantitative. As you said, you can go for a mix approach. That is, you need to check what is the efficiency. Let's say the efficiency is only 80%. Then it is
Okay.
quantitative, right? So you want to achieve the 100% efficiency. That is quantitative. Or you can go for metrics in terms of quality also, right? So as you said, we have to go for a mixed approach.
Okay. Okay, ma'am. Thank you.
So here I have a detailed image of both the examples. That is, the existing product is shown. On that, we do the reverse engineering. What do we do in the reverse engineering? We start with the existing product, study and dissect it, analyze and evaluate. Then we identify the functions and structure, and we go for the improvement. So while going for redesigning, we do the three process. That is, you can go for either original design or variant design or adaptive design. So redesigning may follow any of the three methods that we discussed in week 2 syllabus, and we go for redesigning and get the improved offering. So the process is reverse engineering followed by understanding the existing product, identifying the opportunities, then go for redesign and give the improved product as the output. The goal is not just to copy what exists, but to create something better. So you find out what is the drawback in the existing product. Only then you go for the improved product, right? So whatever is the drawback is addressed here. So it is definitely a better product now. So what is the difference between reverse engineering and redesign? Reverse engineering study an existing product. You understand what it does actually in the present state. You do the modeling and analysis. You do dissection and experimentation, and you focus only on understanding of what is present. After that only you move on to redesign. That is, you improve or evolve the existing product. Then you decide what should be done. Generate improved concepts. You can generate a number of ideas. We will see how to generate more number of ideas in the upcoming weeks. Then we develop and implement the redesign. Then we focus on improvement while doing the redesign. So this is the flow for redesign. That is, existing product is taken, reverse engineering is done, functional understanding is done, then you go for redesign to get the improved product. So by now I think you would have understood what is the difference between reverse engineering and redesign. So why do we need reverse engineering? It saves time. First of all, see, you have some existing thing already. You should understand what is happening. Only then you can design a better product. Otherwise you may design a product which is same as the existing one. So doing reverse engineering is very important. So what is the motivation for reverse engineering? The product development is best understood through actual product developmental activities. So only when you do reverse engineering you can understand the existing product. Then working with an existing product provides a concrete experience. The students or designers can understand how things work, why they work, and what can be improved. So once that is done, you can go for redesign. So first, let us see what is called learning cycle. With that, we will understand how reverse engineering is done. So first thing, you need to get a concrete experience, engage in reverse engineering activities on existing product. You would have seen 3 lab exercises by now, I think. So you need to engage in reverse engineering activities on an existing product. I think you would have seen an example with printer or mixie, I suppose. So with these examples, you gain an experience. Then reflective observation is the second step. That is, you analyze and reflect on what was observed and experienced. So observation is very important. After observation, you go for abstract conceptualization. That is, you formulate the concepts. That is, you come up with ideas or new concepts, principles and models from the observation. So you experience, you observe, then you come up with new ideas. That is, you formulate concepts. Then active experimentations. Apply these concepts by designing, modifying, or improve the product. This is the fourth step. Once you experiment it, you will know what are the drawbacks in the new design. Then again the cycle repeats. So after you get the new experience, you create a new product. In this product you may have some drawbacks, then you again go for experiencing the new product, then this cycle repeats. So this is called learning cycle. That is, you experience, observe, formulate new concepts, then apply these concepts and do the improved product. So I think now you would have understood how reverse engineering works. Now let us see what is the reverse engineering and redesign process. So you have to select an existing product, then you have to do reverse engineering, develop, redesign, and implement the concept. For that, you need to understand the lab exercises properly. Only if you follow up the lab exercises and do the subjective assignments, it will be easy for you to understand what is reverse engineering and redesign process. So at the end of this class, we'll discuss about week 4 subjective assignment, which will be helpful for Wednesday's submission. So now let us see what is scoping the new product development. See, now you want to redesign or design a new product. So at that time, you need to decide which technology to follow. For example, you want to make mobile phones, you cannot follow the technology which was used for designing Nokia phones. So that is completely old and it is not in today's practice. And you have to either work on current technology or you have to work for the future. That is decided by the S curves. So any technology follows the S shape. That is, initially when the technology is introduced, the growth or the benefit from that product will be, performance will be slower. Then after few days the performance growth will be very fast. Then at the end, that is at the saturation of the product, again the returns from the technology will be poor. So when you are investing your money on a technology, you cannot invest it when you are in the saturation region. That is, if it is in the end of the S curve, if you're investing, your competitors may invest in the future technology and they may grab the market. So it is very necessary to understand the S curve and then go for investment. So what to develop is what you have to decide before you start the process. You need to get task clarification, you need to do technology forecasting and S curve analysis. That is, you check what are the technologies available for making the product. Once you check that, you find out where the stages, that is in introduction stage or growth stage or maturity or saturation stage. It is not advisable to invest your money when the technology has reached its saturation. If you are investing the money in the initial stage, even if the returns are not good, in the future you'll get a huge growth, so it's fine. But if it has reached saturation, it is not advisable. So after getting task clarification, you need to do technical questioning and form the mission statement. Once these things are done, then we can easily go for product design. So what are the possible development choices here? Completely new technology is one option. Refinement of an existing product is one option, or you can go for product variant. So these are the options we have. Based on that, we have to choose any one. Then we need to do technical questioning. Technical questioning means only when you question, you will know more. So you have to ask a lot of questions to yourself. That is like what the problem is actually about, what implicit expectations and desires are involved, are the customer needs, requirements and constraints appropriate. Like this, you have to ask a lot of questions so that it will it will get refined, you will get more clarity, and you can restate the design problem in a better way. So what are the characteristics required? Like these, you can ask any number of questions. The team has to discuss among itself, ask questions to one another, so that you can get more clarity and you can refine and restate the design problem. That is the advantage of going for technical questioning. So even in our classes, the faculties always used to say, you have to come forward with your questions, only then you will get better knowledge. So same thing is applicable here. Technical questioning helps the design team gather additional information and continuously challenge its understanding of the problem. So after questioning, you form the mission statement. So what is the mission statement? It gives the right direction or purpose and commitment. So a mission statement conveys an exciting vision of the new product and project goals to the entire team. See, when we work as a team, um, every person may not be able to communicate with each other properly. So they may get deviated from the goal. For this reason, we have to fix a mission statement first. So focus the design efforts, define the project goals, translate the business case to the development team, establish task schedules and milestones, provide guidelines for the design process, and this reduces conflicts within the design team. So mission statement will tell you what are we developing, why are we developing it, for whom are we developing it, and what are the constraints for developing this product. So all this is clearly mentioned in the mission statement so that it will give clarity for all the team members. Only then the team will work towards a particular goal. Otherwise, each one may deviate from the goal and we will not be able to achieve our goal properly. So what does a mission statement do? It covers all these elements. That is, it describes the product, it gives the key business or humanitarian goals, primary market, secondary market, that is, for whom are we designing it, the assumptions that we follow in this design. It mentions about the stakeholders, it covers them. Then the avenues of creative design and the scope limitations. So all these are mentioned in the mission statement. Each element has a purpose. For example, description about the product tells what is being developed, and the goals tell why it is being developed. Market means who are our customers, because only if we understand the customer, we can design a proper product. And what are the assumptions? All these elements have a particular purpose. When we design a mission statement, we should not miss any of these elements. And good mission statement is concise, focused, and clear. So here is a mission statement for designing a fingernail clipper. So we want to design a nail clipper. For that, we need to cover these elements. So first one is product description. So what does the product do? It remove and file excess fingernail length. So that is the product description. After you design the product description, you need to tell what is the business goal. So 6 month development of beta prototype, then 30% profit margin, initial 5% market share, then supplement fingernail polish business. So these are the business goals. You need to tell all this and form a proper statement. Then you tell what is the primary market and secondary market. So the primary market is to cover all the ages, then focusing on fingernail nail polish users. Then secondary market is knife collectors and business executives. So you need to understand who is your customer. Then what are the design opportunities? So what are the opportunities you have? You already have so many nail cutters, so you can work on ergonomic shape, then store or capture nails. So how do you collect the waste nails? That is one option. Then you can have compact storage or ease of cutting. All these areas you can work upon. Then where there is a scope, you can go for different material choice. That is, you can go for steel or moldable plastics. So a mission statement is going to cover all these elements, and then you form the mission statement. So what is the mission statement? To design and develop an ergonomic, easy cutting fingernail clipper with integrated nail capturing capability, crafted from durable steel and moldable plastics to deliver a clean, comfortable grooming experience for everyday nail care users while capturing a 5% market share within 6 months. So this is how your mission statement should be. It should cover all the aspects, that is all the elements that I listed here. Okay. So this is an example of a mission statement. If you give a statement like this, all the team members will have a clarity on what they are working for, and only then we'll be able to design a good product. So by now I think you would have understood. Mission statement gives a focused declaration of what the new product aims to achieve. It includes purpose, target user, main goals, and success criteria constraints. Some of the constraints may be like cost, size, and regulations. See, you want to achieve all that, but within certain cost. Only then the customer will be able to buy it. So you have to mention all that with clarity in your mission statement. Why it is important? It guides the design decisions, it prevents future creep, then aligns all the team members. So here are some of the examples that you can go through. For example, one, our mission is to create a foldable electric wheelchair for air travel that fits into airline cabin baggage rules, ensuring comfort, safety, and easy maneuverability for passengers with mobility impairments. So this is one of the mission statement for designing an electric wheelchair. I have one more example: to design a low-cost solar-powered irrigation pump for small farmers in arid regions, delivering efficiency, durability, and easy maintenance. So, what is the structure in these two examples? They first mention the product type, the target audience, core benefits, and constraints. So, this is how you have to form a mission statement. So, what is the role? It keeps the focus of the customer need, provides a yardstick for concept evaluation, acts as a contract between stakeholders, and it reduces time wasted on irrelevant features. So, if you don't say what is the mission, the team members may go in the wrong direction and the time will get wasted. So, in order to avoid that, we need to give a proper mission statement. So, I have taken one example, which is redesign of a backpack. So, what is the first thing that you have to do? You have to do reverse engineering first. So, when you do reverse engineering, you analyze what are the features present in this existing backpack, what are the functions, what are the components, usage, customer needs, and existing limitations. After finding it, you do the technical questioning. So, what is the real problem with this bag? Maybe this may not have a rain cover. Nowhere it is mentioned that it has a rain cover. So, the real problem may be absence of rain cover. What are the implicit expectations? Some customers from rainy areas may expect that. Then, what must the product have or not have? It may be heavy, so they want a lightweight bag that can be improved. What can be improved? What are the technical conflicts? So, like this, you can have 10 technical questions. Once you do the technical questioning, you form the mission statement. So, we need to prepare mission statement covering product description, goals, market, assumptions, stakeholders, design opportunities, and scope limitations. So, if you follow this procedure, you can redesign your backpack. That is, existing backpack, do reverse engineering, technical questioning, and mission statement. After that, you go to redesign. The redesign can be done by any of the methods which we discussed in week 2 and week 3. So, understand the existing product, ask the right questions, define the mission, and create a better solution. So, with this, week 3 is over. That is, reverse engineering is a learning from existing products. That is what we studied first. After reverse engineering, we can go for redesign. That redesign can be done by original or adaptive or variant method. Then technical questioning clarifies the real needs. Then mission statements keep development teams aligned and on track. So hands-on analysis develops critical design thinking. That is why we have those lab sessions. Please make use of those lab sessions. Okay. So now we'll go to the current week, that is identifying customer needs. So understanding the customer needs is the most important thing in design. So customer needs are the foundation for developing a product that satisfies the customer. So customer need analysis includes gathering raw data from the customers, interpret the raw data in terms of customer needs, then organize the needs into primary needs, secondary needs, and tertiary needs. So, after you organize the needs, you have to establish the relative importance of the needs, reflect on the results and the process. So, what is the overall flow? After you form the mission statement, you do the customer need analysis. After doing customer need analysis, you prioritize the needs. That is, when you do the survey or when you collect the data, raw data, you may have hundreds and thousands of needs, but you cannot design a product which cover all the needs. It is not possible practically. So we'll prioritize the customer need list, and after that we will work towards the prioritized list or prioritized goals. So this 5-step process is presented in identifying the customer needs. So first we'll understand what is a Cano diagram, and after that we'll go for the different needs which are expressed by the customer. So if you observe the graph here, you have performance versus satisfaction, and there are 3 curves here. The first one in the red color is basic performance, which is a must be case. 1 minute, kindly excuse me. I'm sorry. So the first one, that is red color graph, is basic performance, that is must be. For example, let us assume that you plan for a tour and you're booking a hotel. Okay, so when you book a hotel, you expect certain basic performances. For example, you expect a clean bed, and let's say you're going to a hill station, then you expect hot water in the for bathing purpose. So that is basic performance. All these things you will not look for while looking at the catalog, but if this basic feature is not available, you will not at all be happy with the room, right? So poor performance lead to high dissatisfaction, that is this red line. Then you have expected performance, that is better performance lead to higher satisfaction. For example, in the same room you have let's say you have very good wi-fi, but that is not a basic thing. Basic one is cleanliness, a good bed, and uh, a good room to take rest, get ready, and go out for outing. So that is basic. Expected performances, if you have a wi-fi, if you have a tv, then it's good, you have an interest for that. But if it is not available also, it's okay, it will not get such a bad impression. Okay, that is expected performance. Let's say they decorated the room according to your preferences, that will give you a delightment, but it is not mandatory for you. It will make it so attractive, it will give extra happiness for you, but that is only for delightment. That is the third graph, green color. So you need to understand the needs according to this Kano diagram. That is, you need to understand what is the basic requirement expected by the customer. Then you need to understand what is the expected performance by the customer. Then you need to understand what will give a delightment for them. Yes, Rishabh. Yes. Hello.
Ma'am, I have a question.
Yes,
Yeah,
yes,
ma'am.
please.
Am I audible?
Yeah, yeah.
So, ma'am, my question is like
Mm.
just now you mentioned an example of a hotel. Okay,
Yes.
so hotel comes under service design. That is
Yes.
non-tangible design, designing the non-tangible thing like a UX UI or a software or hotel. So, in this case, how can we do the reverse engineering part? Like
No, no,
we
no.
can, is it?
Yes, Rishabh. Actually, I started with mentioning an app for booking a hotel. So while booking the app itself, um, for basic features, when you're creating the app, you must filter out. Okay, if their
Yeah,
rating is not good. I concentrated on the app design. Maybe I got a call in the middle and I got disturbed. Maybe I didn't mention it twice. See, you are designing an app for booking hotels. So when you decide the app, you can filter out, right? So what is the basic performance, or what is expected by the customer, and what is going to give delightment for the customer. All that you can filter out. And if you have different criteria for analyzing these expectations in the app, then it will give um, more satisfaction for the customer. So if you're designing an
yeah.
app for hotel booking, then you can make it. As you said, we cannot go in the surface sector and do the reverse engineering. That's right, you got it correctly. Yeah, you have a good
No,
understanding.
so because
Mm.
I am also studying service design, no. So in service
Okay.
design, I was a bit curious that how can we do the reverse
Mm.
engineering, or even if it is possible in the
Mm.
non-tangible format to do the reverse engineering and stuff like that. So that's why I had this question.
Okay, okay, Rishabh, thank you.
Yeah,
Uh,
thank
so,
you.
so this is your Kano diagram. With that, you can classify what is the basic requirement, what is expected, and what will give delightment for the customer. So, customer satisfaction depends not only on the functionality, but also on the customer expectations and delight. So, if you refer to lecture 9, you can get more about the Kano diagram. This is a very important topic which will give you more clarity on the need analysis. So moving on to the next slide. So there are 6 types of needs which are listed here. The first one is direct need. The second is latent needs. Third one is constant needs, followed by variable needs, general needs, and niche needs. So direct needs are very clear. That is, the customers can easily identify and express them, usually obtained directly from the customer statements itself. For example, if you're designing a phone, direct need is like, I want this feature in the phone. Maybe I want it of lightweight. Like that, they'll tell you directly. Latent needs is the customer may not express them directly. They themselves would not have noticed it, but they want that need. So, need probing and observation is needed to identify those needs. For example, um, we may not use both the hands while using our mobile phone. Many of us want that feature, like all the facilities should be easy to access with a single hand. But nobody expresses this need explicitly. None of the customer will be able to say it, will be able to identify it and say it, but this is expected by all the users. This is a latent need. So we have to do a lot of observations and then find out, okay, this need is there, like that. Then constant needs. So intrinsic to the product task, it remain important whenever the product is used. For example, you're using a mobile phone, it should be safe and secured. There should not be any risk in using that phone. For example, nobody should hack our phone, or it should be secured for using our payment apps. So all these things are constant needs. Whenever we are using a phone, that need is mandatory. Then fourth one is variable needs. That is, it may change with the technological developments. It can disappear when the technology changes, or it keeps varying from person to person. That is, maybe if you say 5 years before, we did not expect this camera quality. It was only in the luxury phones. Now it is not at all mentioned because all the camera qualities have improved to some extent. So that is a variable need. The fifth one is general needs. That is, everybody wants it. For example, everybody wants a good connectivity. Everybody wants messaging features. So these are general needs. It applies to almost everyone in the customer population. The next one is niche needs. That is, it applies only to a smaller segment of the market. Let's say some people want a very good um, what do you say for writing. That is, you will sometimes artists want to draw, no, they want a digital pen for drawing on the tabs and all. So a smaller segment,
Stylus.
stylus, yeah, a smaller segment may want a stylus for taking a class or doing a digital drawing. So all this is niche need. It is not expected by majority of the people. It is a need of a smaller group. They want to have that as an extra feature, but it will cover only a small segment of the market. So these are the six needs: direct, latent, constant, variable, general, and niche needs. So understanding the types of customer needs helps in better product planning, prioritization, and customer satisfaction. Only when you understand the different types of needs, you can design better. So how do you gather these information? How do you get the customer needs? There are different methods for that. Where some of the methods are interviews. That is, direct interaction with the customer will help you give information about the customer. Then it provides high information for the effort involved. You get a lot of information, but not everybody will be available for interviews. That is the problem. It cannot be done for a larger group. Then second one is questionnaires. It is useful for collecting information from larger groups. So it generally provides lower quality information than interviews. The third one is focus groups. That is, discussions with a group of customers. Instead of having one-on-one, we discuss with a group of customers so that you can get collective information, useful for identifying common needs and reactions. So what is important for many people can be gathered using focus groups. Then fourth one, you act as a customer itself. That is, you be the customer, experience the product from customer's point of view, and understand their needs. So only when we are in their shoes, we can understand the situation, right? So like that it is. So it helps reveal needs that may not be explicitly stated. So using the right approach helps uncover accurate and meaningful customer needs, leading to better products and higher customer satisfaction. So these are the four methods through which you can gather ideas. Then I have described about the interview method in detail here. So you ask, that is, what is their like dislike method. That is, you ask a question, what does the customer normally do? Then the customer's statement, you want to design a phone, what do you do with the phone normally? Like that you ask. Then what do you like about the phone? What do you dislike about it? What should be changed? Like that you ask. Then you also ask them for rating so that you can decide which is more important. So this is how you design one like dislike method form and then collect the data. A structured interview form can be used to convert customer comments into interpreted needs. In an interview, you can meet one on one and then fill it, or sometimes you can ask them to fill it. So this will give you better idea so that you can understand their need. So a customer statement is not customer need. The design team must interpret what they are trying to say. Sometimes they may not be able to state it properly, but you need to understand it, interpret it, and clearly understand what is the need of the customer. A statement is different from need. Okay, so that is very important. And see, this interview method is for direct needs only. The latent needs cannot be obtained from questionnaire or so. So for that, you need to do observation. That is what I mentioned in the previous slide. We need to observe and find out the latent needs by ourselves. So we need to study the use pattern or activity of the customer. So first thing, various activities involved in the life cycle of the product is studied. So right from purchase to disposal of the product, how they use the product should be studied. The sequence of activities that they perform every day with that product should be studied. For example, if we take a mobile, once the customer purchases it, what are the things that he is doing with the mobile? How is he using it throughout the day? How he is using it in its night time? All that should be studied. With that, we have to make the activity diagram. Only then we can understand what are the needs of the product, how the and then you can identify the latent and indirect needs. So you have to consider the purchase, transport, unpacking, how he's storing it, how he's using it, all that should be studied. Right from purchase to disposal should be studied. So studying the customer use pattern and activity flow helps uncover latent and indirect needs that lead to better products and higher customer satisfaction. So here's an activity diagram. Let's say he's buying a nail clipper. Okay, so from purchase, how it is delivered, how it is packed, because if it is a fragile product, the transport is also important. Then unpacking is also important, because while unpacking, the customer should not break it by mistake. So all those things are involved. So after he buys it, if the nail clipper is so small, maybe he'll add a feature to it. He may add it to his keychain, then store it somewhere and then use it. He may use it for only clipping. He may use it only for filing. Then he may throw the product after using for so many years. So this is the activity diagram. You have to observe the life cycle of the product, then make this diagram. If you do this, you can understand the needs. That is, from start to end, you have to understand. So organizing and interpreting the needs. Now you have collected the need data. From the data, you cannot go to conclusion without organizing it. So organizing the data or grouping it and categorizing it is very important. For that, you need to do affinity diagram. Affinity diagram means you organize the large amount of data that you have collected, you group it into different categories, then you identify what is common in that, then you create a structured representation of the customer requirements. So here I have shown one affinity diagram. Here you have collected so much data, then you have grouped it under 5 heads. The 5 heads are portability, performance, energy, safety and reliability, and convenience. So what the customers expect in portability, they want it lightweight, they want it easy to carry, easy to store, compact size. So this is what they want under portability head. And as far as performance is concerned, they want um, good heating, then good temperature control. So like that, they want it under performance. Then what about energy? Every customer wants less power consumption. That is what is the expectation of the customer under energy head. Then what is expected under safety and reliability? They want stability, overheat protection, durable, and long life. What is expected in convenience? They want it to be easy for operation, simple control should be there, it should be user friendly, and it should be easy for cleaning. So these are the expectations. Only when you organize the needs, I mean the data, you can get this clarity. So this is done by affinity diagram. So activity diagram is to understand the needs of the customer, that is the latent needs to be specific. You can conduct an interview and get the needs, but for indirect needs you have to go for activity diagram. After that you have to organize it using affinity diagram method, that is you group it under different heads. If you do that, you will get the consolidated needs. That is, what are the needs now? It should be compact and lightweight. It should have good heating and temperature control. It should be easy to carry, constant temperature distribution, less power consumption, then electronic stability. So all these things are done to understand the needs properly. So after you get the needs, you need to prioritize the needs. Let's say he's designing a the designer is designing a mountain bike. So there are so many needs expected. You cannot design which cannot design a bike which will satisfy every need. So what we are going to do is we are going to prioritize out of 1 to 5. So 5 gets the highest priority. If you see here, safe in crash, long lasting, fits a wide variety of bikes. So these are the mm, higher priority customer needs. That is, you want to design suspension fork. This fork should be safe first, and it should be, all these things are higher priority. So your goal is to hit the higher priority needs first. Then what is the next one? Preserve steering characteristics. It should be of lightweight. Then you say it should reduce hand vibration. Then it allows easy travel on difficult terrain. Like that, you rank it or you prioritize the customer needs. So the key point is the customer needs are collected, organized using affinity diagram. Then you give importance rating and you get the prioritized need list. So the ones with 5 rating are going to have higher priority. So after that, you form the product specification. So the key question is how a subjective customer, how can a subjective customer needs be translated into precise targets for product development? So product specification means you should have two things. One is metric, the other one is value. For example, always they said easy to carry. Easy to carry means you cannot specify a product like that. That is the need. It should be easy to carry. But how do you give that as a product specification? You have to mention the metric, weight, you have to mention the value. So here it's a combination of metric and value. The metric is weight and the value is 1.5 kg. So weight less than or equal to 1.5 kg is acceptable for the product. The product should be easy to carry is customer need. Weight less than or equal to 1.5 kg is the specification. So we understood the needs only for forming the product specification so that we can go for a design. So our specification should have two things in it to give clarity. One is metric, the other one is value. The specifications establish precise and measurable details of what the product has to do. Specifications for a new product are quantitative, measurable criteria that the product should be designed to satisfy. So I think by now product specification is clear for you. So from needs, we have arrived at product specification now. So this is your week 4 syllabus, and this was your assignment question for week 4. You need to submit a file. You can include your name, a product name. Then you can choose a product of your choice, or you can go for the product which was used in the laboratory exercise 3. It is a drill bit, suppose. Then you have to address the following points. That is, you have to write about product evolution, the tools needed for dissection, that is for reverse engineering, what are the tools needed. Then the pros of the product and its manufacturing method, what are the products present inside this, and what are the manufacturing method. Then you need to prepare an assembly chart. Please mention your observation and comment. Whatever you observed while doing this reverse engineering, you please mention. This assignment will be evaluated for 100 marks. And with this assignment, um, 4 is getting over. That is subjective assignment for week 4. And you also have um, 10 MCQ questions. You have to submit both by this Wednesday. So this is week 4's takeaway. We analyzed we saw how to get the customer needs. We did customer need analysis. Then from the customer need analysis, we formed what is product specifications. So I think it's clear now. From next week onwards, we will discuss 1 week syllabus at a time. From next week onwards, we'll have some numericals also. Every Monday, we'll discuss that week's syllabus, and we'll discuss some problems and laboratory assignment. Is it clear? Do you have any doubts? Yes, Rishabh, please.
Ma'am, I have submitted, like in week 1, we had 2 assignments. One was the MCQ and the second one was the written part of it. So I have not yet got the result for the first assignment that I have submitted, like the written part of the week 1
Uh,
assignment.
Actually, I have corrected your assignments, but I think it will be released on August 19th or after that, because the last date for correcting um, will be 10 days after you submit. It'll be in hundreds of numbers, right? So it is not possible to release the score immediately for subjective assignments.
Okay.
MCQs will be automated because we feed the answers. It will be done by the computer, so it can happen quickly. But subjective assignments, I need to manually correct them. So I'll be given 10 to 12 days time for each assignment. Week 1 correction is over, but I have 2 more days time. So it will be released after 19th, I suppose. After 19th of August.
Okay, ma'am. And secondly, the
Hmm.
exam that is going to be conducted for this functional and conceptual design. So, will there be only the MCQ part or also the written part?
Um, I don't know. No written part will be there, but problems might be there. Problems will be there for solving. Written part might not be there. Maybe 1 or 2 fill-ups will be there. You're not going to write paragraphs. This laboratory exercise is for understanding reverse engineering and all that. This will be um, contributing for your assignment marks only, not in the
Okay,
subjective
so
exercise.
there won't be any sketching part or anything like that.
No, because it is done in the computer. It's not a written examination, so you will not have any. Yeah, I don't think it'll be there. I need to confirm with professor once. Can I answer by next week, Rishabh?
Sure, sure, ma'am, sure.
Okay. Hmm.
Okay.
Any other doubts, Rishabh? What about your assignments? They are all fine. Week
Yeah,
1 to week 3.
yeah,
Hmm.
I have submitted
Okay.
all the assignments. I have not
Hmm.
submitted the week 3, the written part of it, but yeah, I have submitted the
Hmm.
week 3 MCQ assignment. And because I'm
Hmm.
appearing for the total 5 subjects this semester.
Oh,
So
oh, you are in which year, Rishabh? You are in which year?
ma'am, I'm not a student. I'm currently doing my business. I have
Oh,
studied
I'm sorry.
design.
Okay.
I've studied
Oh, you're
design.
appearing for 5 subjects in NPTEL itself?
Yeah,
Okay, okay, good.
one is like product design and development. Second is this functional and conceptual design. Third is
Okay.
form and aesthetics. Fourth is user research method. And
Oh,
ergonomic workplace analysis here.
that's great. That's great.
Yeah.
You are
So
eligible
yeah,
for NPTEL Believers Award then. I mean, if you are getting good score in more than 4 subjects, I think you're eligible for NPTEL Believers Award. There is an
I
award for
would I
people who do more courses.
I would love to be NPTEL superstar.
Great, great. All the best for that.
Yeah.
Okay.
I hope for the best. I hope I get a good score. And more than the good score, I love to learn. I'm here to learn more about design and how I can
Okay.
implement and build real products. So that is
Okay.
my core priority right now.
Okay. You completed design engineering from which college?
Actually, I didn't complete it design. I have a background in commerce. I've done BCom, and then I went to
Okay.
design management. There is a college in Pune, MIT Institute of Design.
Okay.
Yeah, so I went there to study design management. It's the amalgamation of design and business management and stuff like that. But yeah, I
Okay.
dropped out of there after 1 year because it didn't match my expectation. So
Okay.
right now I'm studying on my own and giving the design consultancies to furniture industries and stuff like that.
Oh, great,
So
great.
yeah.
NPTEL is a great platform to learn. So I think
Without
so.
a doubt, you know what? I would like to thank you guys. Like, I have learned so much. Like just in this semester, like, well, it's true that you need to make a lot of notes, a lot. So, but the whole learning experience was just phenomenal. Uh,
I'm so
I,
happy to
I,
hear.
yeah, I came to know a lot of things about how to design physical, tangible products. Not just tangible product, non-tangible format also, the service design, the user experience design, the holistic way in which how to look at the design in a very holistic. So yeah, it's a really good learning experience, I would say.
I'm so happy to meet you, Rishabh. I was wondering how many participants would turn up today. I'm so happy that you're so interactive and you're coming forward with so many questions. But
Yeah,
one more thing
yeah, ma'am.
to mention
Hello.
this. So,
Yeah,
am
ma'am.
I
Yeah,
audible?
ma'am. Yeah, ma'am.
Yeah.
Your
Yeah.
connection was lost.
Oh, sorry. So this PPT will also be shared for you. I think it will be helpful for you to prepare for the assignment and exams as well. So
Okay.
I'll look for a way to share the PPT with you through some means. I'll check with the NPTEL host team. So you have any other requirement, Rishabh, from us? Like what do you expect other than this PPT and assignments? What else do you expect from us? Any other
Uh,
supporting?
No, nothing for right now, ma'am, because I'm like, I would be able to give a better review like after 1 or 2 weeks because I will be better prepared for that because I'm making a lot of notes and stuff like that. So I was
Okay.
quite occupied. So this is going to
Mm.
be weekly session, right? The next Monday also there will be session.
Yes, Monday, every Monday, 2 to 4 p.m. And
Yeah, yeah, sure.
before before October 25th, that is before your exam date, maybe one or two additional sessions will be there so that it will be helpful for your exam.
Ma'am, is it possible
Mm.
to conduct a session on weekends, like on Saturday or Friday? Is it possible? If it is possible, I'm just a
Mm.
suggestion.
Actually, I'm working in a college. If I do it from my college, no, it will be of good quality. This is a soundproof room, so that I'm choosing weekdays. Is it
Okay.
possible to join on Mondays?
Yeah,
Because,
yeah, ma'am. It is
mm,
it is possible because
mm,
sometimes it gets little hectic because Monday is a working day.
mm,
Friday in the evening because all the last time I attended
mm,
I used to attend this weekly session of design practices for intelligent product design
okay.
conducted by IIT like Kanpur.
Mm,
So they also have this weekly session. So they
okay.
used to conduct the weekly session by
Mm,
5 p.m. to 7 p.m. on Friday.
okay. Mm.
So that was like one of the best times.
Oh,
Uh,
okay.
so it's the weekend, it's the start of the weekend. You come back from
Yeah.
the work, and that is the only suggestion that if it is possible, I'm not saying that if
Okay.
it is
Okay.
possible.
Okay. So I'll just think over it. Maybe Friday.
Hello, hello.
To 4 p.m.
Hello, am I audible, ma'am?